Hello, good day to you all. Today we will discuss about the governor of the engine. So what is the governor? Governor is a device which automatically controls or limits the speed of an engine by adjusting the amount of fuel injected to the engine. This is achieved by measuring the engine speed and then adjusting the fuel control lever of an engine. So basically there are three types of governor used on board ship. One is mechanical, another one is hydraulic, and last one is electronic governor. So in this video we will discuss about the different types of the governor and some important terms about the governor. So here we begin about the mechanical governor. So in the mechanical governor we can see there are two flyweight. These two flyweight are used to normally control this mechanical governor. These two flyweight detect the engine speed. This rotates vertical direction. When the engine speed exceed the set limit, then these two flyweight will move outwards, and when this speed limit goes below the set speed, that time this flyweight moves inwards. So by this way the fuel control lever is controlled. So from further slide we can see here this this is the governor equilibrium position. Here those two flyweight is in vertical position and fuel rack also in stable condition, and this one is the driving gear which is connected to the governor, and this maintains the governor speed with the engine speed. Here we can see when there is an increase in load. So as the engine load increase, the speed will decrease. Here you can see the as the speed decrease, the two flyweight moves inwards. As it moves inwards, there is spreader spring compress the lever, and this mechanical linkage increase the fuel. Then after increase the fuel, the engine speed also increase, and again it will come to equilibrium condition. When the engine's load decrease, that time the engine speed will increase. So here we can see the two flyweight moves outwards, and the control lever is giving signal to reduce the fuel. So as the fuel will reduce, the engine will run at its set rpm, and again the governor will come to equilibrium condition. This is basically the mechanical governor works. Then we will discuss about the hydraulic governor. Hydraulic governor is basically construction is same as mechanical governor, but it additionally have one oil pump, an accumulator, and a pilot valve, and there is a power cylinder. So you can see here this is the hydraulic governor. This hydraulic governor have one pilot valve. This is a spreader spring. This is a flyweight. This is power piston, and there is a oil supply coming from the governor, or sometimes in some governor this oil supply also come from the sump. So here we can see when there is a uh, engine generator speed decrease, that time the flyweight move inwards, this pilot valve goes down. As a result, this oil in, and it's push the power piston as the fuel will increase. So after fuel will increase, this will again come to the equilibrium condition. And again, when the speed increase, that time the pilot valve will move upwards and the oil will drain from the pilot power piston. Oil will drain, then the fuel rack will reduced. So again, after reducing fuel, the engine speed will come to the set position. That time the governor will come to the equilibrium condition. This is the hydraulic governor. Now we'll discuss about the electronic governor. Here you can see the electronic governor. This the engine, and this is the flywheel. From the flywheel there is a proximity sensor. This senses the engine speed and it gives signal to the comparator and amplifier. This amplifier amplify the speed sense signal. Basically, it compared the uh, measured signal with the set value. Here from the controller we can give the set value of the speed. So here this in this comparator segment, the engine speed is compared with the set speed. So if there is any deviation or offset, it will give signal to the actuator, fuel lever control actuator. This actuator this fuel lever will increase or decrease as to control the engine speed. So here we can see proximity sensor they are used to sense the engine speed. This engine speed signal sent to the comparator unit. The comparator unit is the main part of the governor. It receives a DC signal proportional to the engine speed and compared to the speed set signal. The difference between the measured speed and the set value is the offset. This offset value is passed to the output circuit to the control the movement of the fuel rack actuator. A signal which raises or lowers the fuel rack by an amount dependent on the degree of the offset. This system is stable due to feedback layout. There is a feedback you can see here. This amplifier is sending signal to the actuator. Actuator is moving the fuel rack. So after moving the fuel rack, the engine speed will increase. This increased speed or decreased speed will sensed by the proximity sensor, and this will again feedback to the comparator unit. So this system is more stable. So now we'll discuss about some important terms associated with the governor. This one is hunting. Hunting is the continuous fluctuation of the engine speed around the set speed. So when there is a set speed given to the engine, suppose there is the set speed is 700 rpm. There is, if the speed is jumping to the 720 to 680 continuously, this is called hunting. This happens when the governor is too sensitive and changes the fuel supply even with a small change in engine RPM. Uh, there is a dead band. The dead band is a range where the governor don't have any output action. Normally, the in this dead band range, this governor doesn't operate at all. This in the dead band, this is inversely proportional to the sensitivity of the governor. This isochronous governor, the in the isochronous governor maintains the engine speed constant irrespective of load change. If the load changes also, the in this isochronous governor, the governor speed remains constant all the time. The For this reason, in parallel operation of the generator, this isochronous may cause instability. The speed droop governor is the speed will decrease by a fixed percentage when the generator is loaded from no load to full load condition. This provides a stable working point for each load in case of parallel operation. So from the next slide we will discuss about this. This is the speed droop. Droop is the change in speed between the engine no load and full load speed. Here you can see the speed droop equation: no load speed minus full load speed divided by full load speed. For parallel operation of two generators, both generator droop must be same. If droop is not same, the generator will not share load equally. For example, we can see here that if the governor droop setting is 5%, means the generator speed will drop 5% of no load speed when generator will run in full 100% load. So here we can see in this vertical direction that is showing speed, and horizontal direction load is showing. So you can see this in when the load is 0 and speed is 100%. In that condition, if the governor is isochronous, that time we can see the engine load increase 100% and speed also remains the same, no changes in the speed. But for the speed droop setting, we can see as the engine load increasing, speed decreasing. So at last, when the speed is the load is 100%, the engine speed is 95%. So engine speed drop about 5%. So that's why this generator speed droop is 5%. The full load speed, the difference between the full load speed and no load speed is 5%. So when generator running in the parallel operation, the both generator speed decreasing rate with load, or the both generator droop must be the same. Otherwise what will happen? The one generator will take more load, which droop is less, that generator will take more load, and the generator which droop is more, that will take less load. From the next slide we can see this one. If the two generator running in parallel, here we can see from the this this is the number one generator no load frequency. So this is the number one generator no load frequency. This is number two generator no load frequency. As the generator load increasing, the frequency decreasing. So this point is the busbar frequency. In this point, the two generator frequency matches with each other in the parallel operation. So here we can see the number one generator sharing load is P1 and number two generator sharing load is P2. So total load is P. Here you can see number one generator load is less and number two generator load is more. Here from this diagram we can clearly understand that number one generator droop is more. That's why the number one generator load is also less. Number two generator droop is less. That's why the number two generator takes more load. So for parallel operation, two generator droop must be same. Otherwise, this type of instability may happen. This one generator taking more load, another generator taking less load. So here we can see one hydraulic governor with the speed droop lever. There is a spreader spring flyweight, and here you can see this is a needle valve. This one is called compensating needle valve. This one is the speed increasing motor or speed control motor. This one. So in next we will discuss about this one. This needle valve. What is the purpose of the needle valve? This needle valve is serves to adjust the response characteristics of the governor. So what is do? It serves to adjust the response characteristics of the governor. If the needle valve is properly adjusted after a change in load in the engine maintains the fuel injection volume with minimum rotational fluctuation and time. So after if there is any changes in load, then the fuel rack or the fuel lever governor will change the fuel lever to maintain the engine speed. So the purpose of this needle valve is taking the engine to that specified set speed with less fluctuation and in minimum time. If we close the needle valve, open the needle valve more, that time the governor will be too sensitive, it will be too responsive with changing in load. So that time hunting will occur. So that's why this needle valve adjusting is very important for the stable operation of the governor. In the following cases, the needle valve has to be adjusted. In case where the governor is replaced or serviced, in case where the governor is overhauled, when the viscosity of the hydraulic oil is changed, in case the set position of the droop adjuster is changed. So in this following case, the needle valve has to be adjusted properly. So another one we can see the speed droop adjustment. From this governor diagram we can see there is a sliding fulcrum droop adjustment. So by adjusting this fulcrum or the position of this fulcrum, we can adjust the droop of the engine or the governor. So you can see there is a floating lever and there, there is a floating lever and there is a lever ratio is L1 and L2. The lever ratio L1 and L2 of the floating lever is changed by changing the position of the droop adjuster. Here we can see the droop adjuster. So from the big you can see here. To adjust the speed droop, we need to remove the governor controller cover and change the set position of the droop adjuster. As the adjuster is shifted to the zero direction, the speed droop lessen. At the adjuster gradually shifted in the 10 direction, the speed droop enlarges. Each time the set position of the droop adjuster is changed, the needle valve need to readjust it. So basically this droop adjusting lever we are changing the ratio of this lever. So for correct operation of an engine, the droop the correct operation of the parallel operation of the two generator, this two generator droop adjustment is very important. Then we will discuss about the speed setting motor controller. a motor is equipped with a governor. The purpose of this motor is to changing the compression of the governor spring by rotation of the motor. The motor controller sets the governor in any engine speed. So for in every governor top side there is a servo motor. This basically this servo motor is control the maintain the compression of the spring. So by this way this adjust the speed setting of the engine. In case the regulate the speed manually, we can also regulate the engine speed by manual control knob. And in the here you can see this one is a manual control knob. So in this manual control knob there is a limit switch, two limit switch. There is a lower limit switch, another one is upper limit switch. This upper and lower limit switch is fitted to limit the engine speed in case of overspeed or underspeed. So this limit switch is fitted with manual control knob to limit the engine speed. So that's all for the governor for now. So if you have any question regarding the governor, you can write down in the comment box. Okay, thank you for now.